Okay, so no quiz today, so because we finished it last class, right? So, and we had an exam last class, and I will have that discussion. I still have a few people that need to write it, so I can't get it back to you, but I will talk to a few of you individually about how that went. Some went well, and of course, we always have the other side of things, and we have to deal with that. Now, the last couple days have been review, and that's been nice for some of you. You've been liking doing the same thing again, but now it's actually time to get into, I guess, the grade 11 side of things. So, um, let this go. Okay. The next thing, we're actually going to start factoring trinomials that are a bit more complex. And there's a couple strategies to do these, and the trick today will be, well, should I use this way to do it or should I use the other way? And I guess that's something that only comes with practice. So I guess let's get right at it. Now, what we are looking at today that's a little bit different is, and the title is not going to give that away too much because the title kind of looks complicated. But this is what we're sort of looking at right here. You can see this isn't the x squared x constant that we've been doing before. It's x to the 4 plus 5x to the 2 plus 6. But you can rewrite this as this. Now, that again, you may look at that and go, well, that's pretty complicated still. Well, what you've done is you've taken it and transformed it into the way that we were doing this. Okay? Because now we're going to take a to equal x squared, and now every time there was an x squared, an a gets substituted. So a means x squared. But what we've done is we're kind of doing this in steps. So then I can still get this done the old way I used to do, and then I'll substitute that x squared in. Now, looking at this is not going to help you very much. So we're actually going to do one with, we'll do a few of them with trying this new method so you can start to see how it works. So when we get into the more complex ones, you can, I guess, use the same strategy. Now, I'm going to do a two ways. One way using how I would say that it would be a better way to do this question, but would not be a good way to do a more complex one. And you'll start to see that as we're going through this. Now, the trick is this only works if this exponent is ever 1/2 that one. Okay? So you can see this one's going to work and this one's going to work. So you can have 6/3, you can have 12/6. So I guess my own little way is it should always be this, x to the n minus ax to the, this should be always n over 2 plus c. Okay? If it's not like that, nothing's going to work. Okay? So this is kind of the way that I want you to think about it. Make sure that one's always half, or else these aren't going to work in the first place. Okay, so okay, now this one here, you could just do it like we always did, okay? What two things add to give me -5 and multiply to give me -14? Now, first of all, what would my signs be? Negative and positive. Okay, and the negative should win by 5. Now, two numbers that multiply to -14. That's 7 and 2. Then all I do is I kind of pay attention to the exponent, and instead of a minus 7a plus 2, see, a times a, if I foiled it, wouldn't give me a to the 4. So what exponent, like what do you think I should be putting here? A squared. Okay? Now at this point you should be going, huh? These aren't that hard. This is like we were doing before, but I got to remember to put a squared. Okay? That's why for these ones I wouldn't use that substitution method. But I do want to do the or. You could do it another way using the substitution method. Now, it's nice to learn methods on easier ones. So when you get to the harder ones, I can say, come on, you guys, it's just like that easy one we did, and it helps kind of bring you back, right? So we're going to use the substitution method. So we will let big A equal x squared. Okay? So if, yeah, sorry, because we're dealing with a's here. Okay? So I'm going to let the big A equal the little a squared. So how's that going to work? Well, that would be a squared minus 5a minus 14. And then we would do just like we did above, and we would get a minus 7, a plus 2. Now what is a? What is big A? Little a squared. So then I finish with now bringing this back into here. So that would be a squared minus 7, a squared plus 2. Now, I am assuming some of you at this point going, that's hard. That's kind of complicated. We knew how to do it before. Look, it was like, figure out my two numbers, and then I just had to kind of keep straight. Well, if that's a to the 4, I should go a squared times a squared. That's why I would say when you get doing these, you're going to go, in this method here, I would not do the substitution method. Okay? Where would I use the substitution method more is if you do a couple pages and you saw, say, example 5, A or B. Okay? That's where we might want to start getting into the substitution method. Or, even something up here, we might want to get into the substitution method. Okay? But actually, for those ones I wouldn't either. So this is where really the substitution method comes more in hand. But it is nice to see them used kind of on the easy ones that shows you how it does work. Okay? Now, let's not do any more monomials or with just the simple A. Let's actually do okay. Now, this one it gets kind of complicated looking if you look at method 1 because some is done already, right? But here we have our original question. Now, very similar to the one we just did, but there's an a value. There's the 4y to the 4th, not just y to the 4th. But you can see we can put in a y squared here and a y squared here. Now, always notice this is 1/2 this, so this is going to work. So let's let a equal y squared. And then we get 4a squared minus 11a minus 3. Okay? Now, again, we're going to not change this because, well, we did this, so we could do it like we were doing last class. We're looking for what two things add to give me negative 11 and multiply to give me negative 12. Good. I'm looking for what two signs? Not a positive negative, a negative positive. Okay? And again, why am I being deliberate about that? Because the negative should win, so I want it to be the bigger of the two numbers. Those two numbers are 12 and 1. Okay? So then I would be 4a squared minus 12a plus 1a minus 3. Okay, and then I'm going to do my grouping, right? I will take out a 4a in this first set, leaving me with a minus 3. I will take out a 1 in the next set, leaving me with a minus 3. Then I can take out an a minus 3 leaving me with 4a plus 1. Okay, then you always finish with this step. Well, what is a? Well, a is y squared. So y squared minus 3, 4y squared plus 1. Now, like I said, I personally wouldn't do this one using method 1. I would use method 2. Okay, because method 2, I just have to keep straight that that's a y squared, not a y. And my first two numbers should multiply to give me a y to the 4. So you can see where I came up with this right away using this, right? Okay, so that was done already. And then I'm going to group. I can take out what can I take out of this first set? So if I group this and then group this, I can take out a what? 4y squared, right? 4y squared, I can take out a y minus 3. Plus I can take a y squared minus 3, and then I can take out a 1, leaving me with y squared minus 3. So I got a y squared minus 3 and a 4y squared plus 1. Okay, so these here, I would just all use method 2 in this case, okay? But I want to do some method 2 here. By method 2, I'm talking this way, right? So I'm going to do a method 2 with this one, just to be able to concentrate on how to keep this stuff straight. So I wouldn't do the substitution for this one. What I would do substitution more is, for example, 5. Okay? But anyway, let's do these ones using the first one to be able to keep this straight. Now, I know there's A's and B's in there, but you just got to concentrate on making sure that when you multiply your first two in FOIL, you would get a squared, b squared, and the rest would probably be right. Okay? Now, is there any questions about these two methods while I'm here? Yep. I would say that if there isn't information in brackets, so if there's stuff in brackets, it gets confusing. I would use the substitution method for these. But you see these, they're not really in brackets, they're just, so if it's stuff in brackets, it's kind of like screaming out, use substitution with me, okay? So this one here, I'm going to look for two numbers that add to give me negative 31 and multiply to give me 198. Okay, so this one isn't the nicest one in the world. That's hence why we're doing it, I guess. So what am I looking for signs? Two negatives. So 198. What goes nice into 198? What'd you get? Sorry? 9 and 22. Good. Or 22 and 9, whatever. Okay, so then I would just go 2a squared b squared minus 22ab minus 9ab plus 99. Yep. How did we get the negative 22 and the negative 9? Sorry. Okay, so now you should be able to just group this on your own. So I think these are very easy to do, just the method we've always used. What should we take out of that first set? 2ab, that's the best we can do. That would leave me with ab minus 11. And then the next group, I'll take out a minus 9, leave me with AB minus 11. Okay, so then I got AB minus 11 and 2AB minus 9. Now, if you were to substitute in B, what would you have called your big A? So if you did use substitution, you would make A equal just AB, right? But I think you're creating work for yourself by doing substitution there. I think it works well for those ones, okay? Okay, let's do this one. This is a gooder. Now, can I take anything out? Is the exponents one half the other one or the other one? Okay, so check those things out because you got to be careful on multiple choice. It cannot be factored farther. These might be one of them, right? And if that was saying a to the fourth and an x, or an x to the fourth and an x, it's going to get some of you. Okay, so this one can be factored, and it cannot be, GCF cannot be taken out. So I'm looking for two things that add to give me 10 multiplied to give me negative 24. What would they be? Okay, with signs first would be what? Positive and negative. Good, because positive must win. And what were they? 12 and 2. So 8x to the 4 plus 12x squared, right? Plus, or minus, sorry, 2x squared minus 3. So what do you got to really worry about on this one? Making sure you're not putting 12x and minus 2x, right? Because these two must equal this. And obviously, they got to be both x squareds, okay? So what can I take out of the first set? 4x squared, leaving me with 2x squared plus 3. And I can take out on the second set, I'll take out a negative 1. Good. Leaving me with 2x squared plus 3. Okay. So my answer would be 2x squared plus 3 and 4x squared minus 1. So why is this one a gooder? Is it any different than the rest? Yes, it is. I'm not done. Can I factor 2x squared plus 3? Can I factor 4x squared minus 1? They're both perfect squares. They are a difference of squares. So this would be 2x squared plus 3. This would be 2x minus 1, 2x plus 1. Okay? So, again, if I was making a study sheet, I would get one of these on there because I can't but not put this on my written response. I have to see, do they know to keep going? Okay, you can see where I'm going to give 1 mark or 2 marks. Okay, I have to get those students that are studying, that are paying attention, they're putting this on there. Those are the ones that should be getting 100 on this test, right? That they knew not to stop at that point because it's a difference of squares. Funny thing is, if I just said factor 4x squared minus 1, people would know to do it. But if it's in the middle of the question, they don't, okay? So that's why this is a very good question for, I guess, separating those students that really know their stuff from those that don't, okay? Now, B is just more of a ruse to be able to kind of confuse you, or, sorry, example 4B, A and B, they're the same, we're not going to do both of them, but they are no different than the ones you've ever done before, okay? Just, are the exponents half of the other one? Yes? Can I take anything out? No, so then I keep going, okay? Now again, only my good disciplined students will ask those first 2 questions. Okay, and I'm probably one of the worst ones in here for not asking the two questions before I dig right in. Okay, because you want to do that as a test. I got to go, right? But you ask those two questions, you may save yourself a lot of time. So I'm looking for what two things add to give me 11, multiply to give me negative 12, right? I am looking for what two signs? Positive and a negative. What are they? And 1. Okay, so then you're just going to go 4 cos squared x. Now remember, this is what this means, okay? It means that. When we're putting in our calculator, that's what that means. So that's, and then I've got plus 12 cos x minus 1 cos x minus 3. Okay, so you don't want to deviate off the plan. That's the way we've always done it. We're going to keep doing it, right? Because 12 cos x minus 1 cos x, that's 11 cos x. I get that. Okay, so what can I take out of the first set? Can I take out 4 cos x, leaving me with cos x plus 3. In the second set, negative 1, right? Cos x plus 3. It's always a good feeling, eh? When you get those two brackets looking the same. Must have did something right. And 4 cos x minus 1. And again, what is the nice thing about all of these questions? Is that I could put the question into y1, I can put in the answer into y2, and I will get the same graph. Okay, so the only thing is that would not help you with this question, because if you put this into y2, you will get the right graph, will you not? It's just not simplified enough. So the calculator will not tell you if you've gone far enough, but it will tell you if you've ever gone off track. Because if I did get to the end and I had the wrong answer, I would put in the step before it. And if I got the right graph, I know that's where I made my mistake. But if I still didn't get the right graph, I put in the step before it. Okay? So given enough time, I would find the error. Okay, so we've been talking about all this substitution stuff. Maybe now's the time we should actually use it. Okay? So again, when I see the brackets, that's what I'm thinking substitution. So for this one, I would let A equal, it's kind of obvious. What would it be? A plus 4, right? So then it would be just 9a squared plus a, right? So I'd be looking for what two things add to give me 1 and multiply to give me, what? Negative 90, right? What am I looking for? What would be my signs anyway? 2 positive and a negative, right? Okay, they're two numbers pretty close together. 10 and 9, right? See, when you get in the habit of always putting the bigger one first, then I would not accidentally put positive 9 and negative 10, right? I'm always thinking the bigger one must win. So then I got 9a squared plus 10a minus 9a minus 10. Okay, what would I be taking out of the first set? A is the best I can do. So it would leave me 9a plus 10. In the second set, negative 1, 9a plus 10. I would take out my 9a plus 10. And then a minus 1. Now, if you cannot go any farther, that's where you kind of draw the line. I can't go any farther. It's time to actually put my a plus 4 back in. So that would be 9. Now, this is tricky, right? You've got to actually do it. 9a plus 4. Do you see 9 is multiplying to all of a? So 9 must be multiplying to all of a. If you do not put brackets in there, guarantee you're done here. That's the last step you got right, was the one before it, because then you will get 9a plus 4. It's really 9a plus 36, is it not? Really, that's what it means, okay? And then plus 10, and then a little set of brackets here for a plus 4 minus 1. So this is one where it's not nice to do all the way we've been doing before. This one, you see some brackets, use substitution. So that's 9a plus 36 plus 10. This would be a plus 4 minus 1. So the first set would give me 9a plus 46 and a plus 3. What do you think? Kels, was that hard? No? Challenging though? No, not even challenging. I've insulted her. Okay, because she told me it would be the hardest stuff in the world. And it was going to ruin her day. That's how much pressure she put on me. So let's do 1 to 5 all.